Okay, so this is a video about statistical testing or hypothesis testing, and how we can take a sample from a population and then do something with the sample, look at it, and then form some conclusions about the population from where it comes. So this is the kind of situation we usually have. We have a population with a large number of items. We can call these people, and they've all got different properties that would be maybe represented by different variables. And then we somehow take a representative sample. Now, with the way we take a representative sample, of course, varies. Simple random sample, a stratified sample. There's various ways of doing it, but what we want to do is we want to capture the properties of the population within our sample. And then we go ahead and analyse on a smaller scale our sample. Because don't forget, the population might have tens of thousands of items in it, tens of thousands of people or millions of people. It may be hard to collect the data from every single item in the population, but very easy to analyse a smaller section here in the sample. So the theory goes, and it's borne out in practice, is that the sample statistics, so when we look at the mean of the sample or maybe the standard deviation of the sample, or we even look at relationships, maybe like a correlation between two variables, the idea is that the properties of the sample are a good predictor for the properties of the population. So if we take the mean of the sample, we might be able to use that as a good predictor for the population. If we see that there's actually a correlation in the sample, then that might give us some evidence that that correlation might apply to the whole population. Now notice the use of might. Of course, there's always going to be some errors in this, isn't there? Because what if in the population there is maybe no correlation between two variables you're testing, but you just happen to select by random chance people that actually do display this correlation, okay? So we always have to give some kind of confidence in terms of how our conclusion goes. And so we're going to go straight into that type of test here. And so we're going to go back to the population here. We're going to take a sample from the population, and then we're going to draw a scatter graph for our sample. We're looking at variable A, variable B. And imagine that our scatter graph shows us up like this. Now the calculator or any bit of software will be able to tell you the correlation coefficient for the sample. So for these dots, they don't look to have much of a pattern. And the correlation coefficient for the sample is 0.19. Now we could see on this scale here that 0.19 really equates to zero correlation. So with this kind of structure for the sample, do you think it's probably true that there is indeed no correlation in the population? And then what if we actually, from the sample, we got this picture here, where the correlation coefficient for the sample was 0.52, which is kind of moderate positive correlation. Do you think there's enough evidence then from this sample to suggest that actually maybe this null hypothesis is actually false? So we're assuming that there's no correlation in the population. That's always usually the starting hypothesis, that there's nothing going on in the population. And then once we analyse the sample, we say, is there enough evidence in the sample to suggest that this initial null hypothesis is false? Or maybe here we don't have enough evidence to suggest anything other than there's no correlation in the population. Okay. And this is where we actually have to do a hypothesis or a statistical test. It's not enough just to go with these numbers here and look at this scale. This scale only really applies to samples. What we have to do is we have to make a best guess about, well, how do our results then apply to the whole population? Okay, and this is something that actually we generate a magic number called a p-value. Okay. So every statistical test that we care to do will give us a p-value. It's important to understand what a p-value actually does for us. The p-value is a probability value, and the p-value for the test is the probability that the null hypothesis is true. Okay, so maybe when we get this set of data, maybe the p-value is going to be quite high because we can see that the probability that there's no correlation in the population is true is probably quite high if we get this. Maybe if we get this, maybe there's a little less confidence that this statement is true. Okay, so let me switch out now to my iPad, from my iPad to my TI-Nspire. Now on the TI-Nspire, what I've got on screen here is actually a scattergraph, which looks quite similar to the one we've been looking at for the 0.19. And so if I just go through on my menu here, I'm going to work out an R value, the correlation coefficient. So I'm going to go menu, I'm going to go statistics, and I'm going to go for a statistic calculation. And I'm going to do a two variable statistics here because I'm looking at variable C with variable D. And we can go OK. Yep, we can overwrite the cells there. And over here, if I scroll down on the calculator, you'll see an R value eventually down the bottom. So R here is 0.19, which is as given on the page just there. But again, we need to work out the p-value for this test. What's the probability that there is no correlation in the population given this particular sample that we've got? So here we have to go back into our menu, and then we have to look at statistical tests. Okay, so you might have seen that when I did a drop-down menu. So let me just go back to the top here, so in blank space. Now let's try one more time. So we're going to go menu, we're going to go statistics. We should be able to see an option down here, option number 4, statistical tests. Now the statistical tests menu is pretty immense. Okay, we've got so many statistical tests we might like to do. For this one, for correlation, usually you'd go ahead and try and fit a straight line, linear regression. So can you see all the way down, option A is a linreg t-test. So this is what we need to work out a p-value for this particular scattergraph. So linreg t-test, and then we're going to choose our two variables again to be the same as before, C here and D here. All we have to do is choose an alternate hypothesis. So basically our null hypothesis was there's no correlation in the population. The alternate is that yeah, that there is some correlation in the population. So we have this not equal to 0. This is called a two-tailed test. If you're not too sure which direction the correlation might be, positive or negative, we always just choose this for the alternate hypothesis. So let's press OK. Let's overwrite the results. And as we scroll down here, what you've got is actually some values for A and B, which is the linear regression, the line of best fit. But down here, you can see there's the p-value. So the p-value is 0.69, so the p-value is actually 69%. So let's just write down that p-value. So the p-value is actually 69%. Okay, so now think about what the p-value means. The p-value means is it's a value of saying how likely is it that the null hypothesis is true. Okay, so the null hypothesis is no correlation in the population. From our test, in terms of the scattergraph we drew from the sample, we've got a p-value of 69%, so it's 69% likely that there is no correlation in the population. Okay, so obviously that asks the question, well, how low does that probability need to drop before we actually are not very confident at all that there's no correlation? Well, that all now depends on the level of significance you're testing at. And there are different levels we can test at. We're testing at 5% here, which is quite a standard level to test at. So for this one, what we need to do is, if the p-value for our test is low, then the null hypothesis must go. Right? So imagine p-value was 1%, then that would mean it's 1% likely that the null hypothesis is true. So it's very unlikely that the null hypothesis is true. At the moment, it's 69% likely that this is true. So that, yeah, we can be quite confident maybe in in this conclusion that there is no correlation in the population. It's when that p-value gets lower and lower that we've got less confidence in the truth of this. Okay, so if I switch out to this second one here, now you can imagine that if we got this from our sample, there seems to be, moderate correlation in the sample, but is this enough evidence to state that this statement is false and therefore that there actually is correlation in the population? So is this enough evidence to say that there is correlation in the actual population? Well, again, we have to do a statistical test. So we will go to that data now. So if I go back a couple of, so this is the scattergraph, right, which looks quite similar to this. And I'm going to go straight to the statistical test now. So if I go to the top here, so when you're doing your stat test on TI-Nspire, it's good just to see the results at the top here. I'm going to scroll to the left here. I've got data in columns A and B. The laptop's just a little bit slow because I've got lots of things plugged in. Okay, so there's my data. And now here I'm going to go scroll this across, menu, statistics, and then I'm going to go to stat test, number 4 there, and then you see linreg t-test is way down at the bottom here, letter A. Okay, now my variables here are A and B, so A here, B here, and again I'm going to go, the alternate is that there is correlation. I'm not too sure which direction it is. I'm going to press OK. And let's look at that p-value. Okay, so the p-value now is actually 0.123, so that's 0.12389, so that's 12.4%. So if I just go over to here now, we will say goodbye to the calculator, and I'll just go back to the iPad. I can't quite remember now what the p-value was. I was trying to round it up, 0.124. Okay, 0.124. So this is actually 12.4%. Okay, so the p-value is 12.4%. So what does that mean? Well, it means the probability that this is true now has only a value of 12.4%. So it's only 12.4% likely that this is true. So you're a lot less confident, aren't you, with this? But we've got to stick to our significance level of 5%. Only when that p-value drops below this 5% level will we have enough evidence, will we have significant evidence to say that this is no longer true, and we then reject this for the alternate hypothesis. And the alternate hypothesis would be saying that given this information here from the sample, we have enough evidence to suggest there is indeed correlation in the population. Okay, so if p is low, the null must go. The null is always that position of neutrality. There's nothing happening in the population. A little summary of all those steps is here. So notice this is for testing for an association or correlation in a population. So the null would always be like this. Of course, the variables that you're testing for, whatever you're collecting data on, you would replace the actual names here. The alternate is that there is a correlation, okay? And then we go ahead and we test at the 5% level of significance. And this was a two-tailed test, we're not too sure which direction. It can be one-tailed or two-tailed, you might be able to dig into more details for this. But we're testing at the 5% level of significance. The 5% may change to 1%, 10%, 0.1%, depending on the situation you're in. Now we have to go, and this is probably a super important thing, is we've got to select our sample, but it has to be representative of the population, okay? So this is a crucial section number 3. If we don't get a sample that's representative of the population, then all our following analysis is pointless, really, okay? And then here we get a p-value for the test, and the p-value indicates the probability that the null hypothesis is true, Okay, so p-value of 78%, the null hypothesis 78% likely. And then the final thing is, how do we know when we've got enough evidence to reject the null? Well, if p is low, then the null must go. So if the p-value is lower than the significance level, the null must go. So if we go back here, the conclusion over here would be that my p-value was 12.4%, and that's greater than the 5% significance level. So we are going to hold onto the null. And then in words, our conclusion is that there is no correlation between these two variables in the population.